Today we're going to continue our atomic structure unit, and this is going to be the final part of that unit, the periodic trends. We are going to be taking Cornell notes, and so if you're in class, I'm going to be showing you how to put this into your journal, and if you're watching this at home, just make sure that you have the copied paper that has several of these blank periodic tables. We're going to be notating those with different periodic trends as we go. So some of the things that we are going to talk about will be atomic radius, which is the size of the atom, what we use for the general size of the atom, metallic properties, ionization energies we'll be talking about as well, and we'll be talking about electronegativity and electron affinity, and probably in another unit. Okay, so let's go to our first blank periodic table, and we're going to label this. Let's start with a review concept. Let's look at our blocks. So we had in a previous lesson electron configurations, and when we made electron configurations, we said that anything that ended in this part of the periodic table had an orbital in an S shape, and it was an S block. The very first level is a small level, and so hydrogen and helium are included in that S block. So the first thing we need to do is make sure that we color and label these on that first blank periodic table that you have. So this is a time to pause, make sure that you are labeling and coloring your own periodic table. This first one, let's go ahead and make sure that we have it labeled as electron configurations. Okay, there we go. Label it electron configurations, and let's color and label in those parts of the periodic table. Once you've done that, it's also important for us to remember what the parts of the periodic table are. And so on the next blank periodic table that you have, label that representative elements. We had a question on the previous SCA that I did not count for our grade because we had not talked about the term representative elements, but we're going to talk about that. The representative elements are here described as main group elements in the reddish color. And then these are transition elements. We did label those previously in a previous lesson, but these elements here, the ones that have the 1A, 2A, 3A, all the way to 8A, these are representative of all of the types of elements that we have. They are metals, gases, there are liquids in this group, there are metals, as we said, metalloids on that stair step, and nonmetals to the right of that stair step. So all of these that are in this reddish orangish color, those are representative elements. So if you will, on your periodic tables, make sure that you color those in. So choose one color and let that color be your label for your representative elements. It's just these elements here. It will also be useful for you to label these as 1A, 2A, 3A, 4A, and all the way down to 8A. Once you have that colored in, on this same periodic table, because this one is a little sparse, we're going to go ahead and make sure that we have our groups and our periods labeled. So remember that groups are vertical columns and periods are the horizontal rows. So choose a darker color to outline and label a period and a group on this second periodic table. I'm going to label this right here as a group, and I'll just use this right here, this row, as what I'm labeling for the period. And then under each, write down, just as a reminder, what those terms mean. So I've put the definition for group, a vertical column of elements, also known as a family. And we'll do the same for period. We'll go ahead and pause the video and give you a few minutes to catch up before we move on to the third blank periodic table. The next periodic table, we're only going to use the representative elements to demonstrate the next concept. So these are the groups and periods that we're going to be looking at. You're going to label on your own still extended periodic table because all of your blank periodic tables look the same. But we're going to use this to help illustrate atomic radius. Okay, so just using these groups and periods, I'm going to actually just even zoom in a little bit more on just the first few, or the first two groups. And I'm specifically going to look at atomic radius or atomic size as we move down the first group. So as I am looking at the number of energy levels that the atoms have, in the first period, elements have 1 energy level. In the second period, they have 2 energy levels. Let's see. So you still have the first energy level, that is still there. But now we've built upon that a second energy level because there are more electrons, so there needs to be more levels for those electrons to move around in. In the third energy level, you may remember, there are 3 levels for electron placement. And again, we still have that first initial energy level in all of these, but we're having to build extra spaces, extra levels. It's almost like there's extra floors in a building. If there needs to be more space for more people or more offices, then there's another floor to the building. Now in each of these elements, and that one's almost not fitting on the picture, but in each of these elements, we have all of these energy levels that we started with in the beginning. Because we always add the electrons to the first energy level first, and then when we run out of room, we move to the next energy level. When we run out of room there, we move on to the next energy level, and if we need to, we keep on moving up, adding more energy levels as we go. So as we are adding electrons, There's another thing that is equal to the number of electrons when we talk about atomic structure. Remember that the number of protons equals the number of electrons. So as the atomic number is increasing, which is what's happening as we move down a group, the atomic number is increasing, we're going to have more protons and more electrons. And so visually you can see that there is a trend in the size as we move down. There's successively a difference in each of their radii. So the first thing that we need to write on this third blank periodic table, we need to first draw the relative radii and write down this observation. Atomic radius increases as we move further down the group. Now let's take a minute to think about that. Remember that this is the overall size of our atom, but that there are still these layers underneath, and that is what's making the size of the atom having to increase. So take a moment and in your spirals, write down why. We have that atomic radius increases as we move further down the group. In your own words, in your spirals, pause the video, take a few moments, and tell me why. All right, so hopefully you have something written down to the effect that the number of energy levels increases as you move down a group. Hopefully you also have something about number of electrons increasing. Therefore, atomic radius increases as the group and energy levels increase. A couple of things to write down. If you do not have them written down, this would be really good. But these two things right here, valence shell, the valence shell is farther from the nucleus. We talked about what that was in an earlier lesson. They're the outer shell electrons, whatever's in that very outer shell. Also, effective nuclear charge is fairly close. That means whatever that charge is in the very center, it only affects the electrons that are really close to it. And so I like to think of Captain America's shield, where the star is the nucleus, this is the positive charge. It is only really going to be pulling in strongly that inner level of electrons. The outer levels don't feel that nuclear charge as much because they're further out. So the nuclear charge only affects the fairly close electrons. That's going to be it for this particular video. Look for a second installment to finish up the periodic trends.